all of you. Now, in the previous class, children, we have done and discussed these formulas. Sine of a plus b, sine of a minus b, cos of a plus b, cos of a minus b, tan of a plus b, tan of a minus b. The formulas are there. And similarly, we have also done this product of sine of a plus b into sine of a minus b and cos of a plus b into cos of a minus b. Now, beside this, you have to consider this special case which is based on formula of tan of a plus b or tan of a minus b, when one of the real number is pi by 4. So when you apply this formula where tan a is replaced by tan pi by 4 here and here, it becomes 1. Why? Because tan pi by 4 is tan 45, which is 1. So the formula goes this way. This also you need to remember. Now, children, any trigonometrical ratio followed by pi plus minus of real number or 2 pi plus minus a real number will get modified to same trigonometrical ratio with real number x. You already know that when it's multiple of pi or 2 pi, it becomes same trigonometrical ratio repeats along with this real number x. But there has to be a proper sign. This proper sign, which is either plus or minus, depends upon the quadrant where these angles will lie. Depends upon what? The quadrant. And we have already discussed those quadrants, that if you have pi plus x will lie here because pi is the end point here. Pi plus x will lie in the third quadrant and pi minus x will lie in the second quadrant. Same way, 2 pi is on this side, so 2 pi plus x will lie here and 2 pi minus x will lie here. So we now see that all 4 quadrants are being covered by representing in terms of pi plus minus x or 2 pi plus minus x. And accordingly, based on this operating trigonometrical function, we'll put a sign because we know that all are positive here. Sign, add sugar to coffee. You know, accordingly we'll put the sign. But similarly, if you have trigonometrical ratio in terms of pi by 2 plus minus x or 3 pi by 2 plus minus x, that is a real number, in terms of pi by 2 or 3 pi by 2 plus minus x, then this trigonometrical ratio, the operating trigonometrical ratio, changes to its complementary trigonometrical ratio times the angle x or the real number x with a proper sign again. The proper sign will be plus or minus depending upon the quadrant. This again depends upon what? The quadrant. Now you can see that pi by 2 is here and 3 pi by 2 is endpoint here. So when we add minus, we subtract pi by 2 minus x will lie in the first quadrant, pi by 2 plus x will lie in the second quadrant, 3 pi by 2 minus x will lie in the third quadrant and 3 pi by 2 minus x will lie in will lie in the fourth quadrant. So this also covers. This can help also in converting so many formulas that you need to learn are sum up by this flowchart. Okay, so you need to understand this and apply this whenever required. Now let's do some questions from the exercise 3.5. Question number 10, part 4. Now sine square pi by 4, sine square 3 pi by 4, sine square 5 pi by 4, sine square 7 pi by 4. Now let's begin. We write sine square pi by 4 initially, although it's a standard value, sine is 45 degree, we'll put the value later on. Similarly, sine square 3 pi by 4. You know the denominator is 4. And numerator is 3, so we break this numerator 3 in terms of multiple of 4. So we can write this as 4 pi minus pi divided by 4. Similarly, we can write this as sine square multiple of 4 means 4 pi plus pi divided by 4. And similarly the last one, sine square 8 pi minus pi divided by 4. So putting it in terms of multiple of 4, because denominator is 4, so 4 pi. But denominator is 4 pi plus pi, and 7 pi means the multiple of 4 is 8, so 8 pi minus pi. Now this becomes sine pi by 4. This is sine square pi minus pi by 4 plus sine square pi plus pi by 4 and plus sine square pi minus pi by 4. Now, the conversion which I just told you before it, so it will be written as sine square pi by 4, let it be continued this way, let us see what they are converting to. Sine square pi means it will go, and this pi minus 4, the quadrant is, which quadrant it is? Pi minus pi by 4 is second quadrant. second quadrant sine is positive. So we'll write this as positive. That is sine pi by 4 whole square. Okay. Similarly, what about this pi plus pi by 4? Pi plus pi by 4 is which quadrant? Third quadrant, where sine is negative. So we'll write this as minus sine pi by 4 whole square. Correct? And then we have plus. This is which quadrant? Pi minus pi by 4. Pi minus pi by 4. Sorry, it is 2 pi. 2 pi minus pi by 4. 2 pi minus pi by 4 is which quadrant? Fourth quadrant, where sine is again negative. So we write sine pi by 4 minus sine pi by 4 whole square. Now, you can see that this becomes sine square pi by 4. This is also sine square pi by 4. Minus sine pi by 4 whole square is again plus sine square pi by 4. This is also minus sine pi by 4 whole square is plus sine square pi by 4. So how many sine pi by 4 are you getting? 4. So become 4 times sine square pi by 4. And you know that this is 4 into pi by 4 is 45. So 1 by root 2 whole square, which is 4 into 1 by 2. So the answer is what? 2. So the conversion which I just told you is being used in this question when you get sine pi minus pi by 4, sine pi plus pi by 4, 2 pi minus pi by 4. Okay? Now, coming up to this question now. Tan pi by 12, tan pi by 16, tan 5 pi by 12, tan 7 pi by 16. Now, what should we do in this question? Here, we'll write the first two as it is because we are not going to break them. First of all, we have to break the angles which are being expressed in terms of 5 pi and 7 pi. Now, how can we break it here? Since the denominator is 12, if we break in terms of multiple of 12 as 5, it will be, the difference is too large. So what we do in that case, we look for the half multiple of 12. What is half multiple of 12? 6. So we break this 5 pi in multiples of 6, which because this 5 is very close to the half multiple of denominator. So we shall be writing 6 pi minus pi upon 12. So when the numeral value is very far away from the denominator value, then we look for how close the numerator is with the half value of the denominator. Okay, so we find it is very close to half denominator as 6. So 6 pi minus pi. Similarly, in this case, 7 is very close to the half multiple of 16, that is 8. So we shall be writing here 8 pi minus pi by 16. Now children, see what it transforms to. Tan pi by 12, tan pi by 16, and this will become tan pi by 2. 6 by 12 is pi by 2 minus pi by 12. And same way this will become tan pi by 2 minus pi by 16. Now, here you have to convert now. Look at the quadrant first. Pi by 2 minus theta is first quadrant. This is also first quadrant. And tan pi by 2, the operating trigonometrical ratio changes to what? It's complementary. Okay, so it becomes tan pi by 12, tan pi by 16, with pi by 2. With pi it changes to pi and 2 pi. Pi and 2 pi changes to same trigonometrical function. Sine will remain sine, sine will remain sine, cos will remain cos, cos will remain cos. But here, in terms of pi by 2 or 3 pi by 2, it changes to its complementary. So it becomes cot pi by 12, and that becomes cot pi by 16. And the answer is 1. Why? Because tan pi by 12 into cot pi by 12 is 1. Reciprocal ratios. Tan pi by 16 and cot pi by 16 product is also 1. So the product of this entire function becomes 1 into 1, that is 1. Okay. Now let's do question number 15. Tan 25 value is being given to us as x, and you have been asked to prove that this expression with tan 155 degree minus tan 115 degree 1 plus tan 155 degree into tan 115 degree will take up the expression 1 minus x square upon 2x. If somebody looks at this expression, and with this expression he will say that this is the formula of tan of a minus b. But what is tan of a minus b? Tan of a is 155 minus 150. That turns out to be tan of 40 degree. But tan 40 degree cannot be expressed in terms of 45 with a standard angle. Can it be? No. With 90 or 180 or 270 or 360. So what we do is we write we try to express these angles 155, 150 in terms of 25. So if we take up the first angle, 150 degree. 115 degree can be written as tan of 90 plus 25. And you already know that when it is 90 or pi by 2 plus theta or plus x, it changes to what? It's complementary. So it becomes cot 25 first of all. And cot 25 will be taken the value 1 upon x. But what is a proper sign? This belongs to which quadrant? This belongs to second quadrant. 90 plus theta goes in second quadrant where tan is negative. So minus comes up here. Similarly, tan of 155 degree. Tan of 155 degree can be written as 90 plus, or you can change it to 180 minus 45. That will be better. With 180 minus 45, it remains tan 180. So it remains tan. Tan of 25, sorry. 25 is here. Tan 25 degree. Tan 25 degree. And tan 25 degree will, and this is 180 minus theta. 180 minus theta means which quadrant? It's again second quadrant where tan remains negative. So minus tan 25. Now we substitute these values in the expression now and simplify. That's it. So we get this is 155 is minus tan 25, that is, this is minus x and this is minus 1 upon x. So we substitute the values in the expression and simplify. We get minus x minus of minus 1 upon x, then 1 plus of minus x into minus of 1 upon x. So what do you find? Then this cancels, this minus minus becomes plus, so it is 2. Denominator is 2. Whereas the numerator, when simplified, becomes minus x square plus 1 divided by x. And this takes up the formula 1 minus x square upon 2x. So the first approach, when you look at the formula, those who remember the formula will apply this and convert to tan 40. But tan 40 cannot be expressed in terms of tan 25 with 90 or 180 or 270 or 360. So we look at these angles, two angles which are involved, we express them in terms of x to get, we do it 90 plus 25 and we write 155 as 180 minus 25. And then we get in terms of 25 so that we can express these values in terms of x. And we put those values in the expression and we get the results. Got it? Now, question number 17. Children, you remember we have done the question on cyclic quadrilateral where opposite angles are supplementary. This question is based on triangle. If ABC is triangle, then we have to prove this expression. Sorry, we have to find the value of this expression. Okay? So we know that if it's ABC is a triangle, then sum of these three angles A plus B plus C is going to be pi. From there, we can express each of the numerator now. The numerator can be written as tan of B plus C can be written as pi minus A plus C can be written as pi minus B, and similarly this can be written as pi minus C. Whereas the denominator is always in the is already given in a standard form. So tan of pi minus A is second quadrant. That's not this pi minus A is second quadrant. So it becomes minus tan A. So it becomes minus tan A. This is which quadrant? Pi minus theta. This is fourth quadrant. In fourth quadrant, tan is negative. So it becomes minus tan B. Then about 3 pi. 3 pi, children, you know, 3 pi lies on which side? Pi, this is 0, this is pi. This 2 pi lies here, then comes 3 pi. And with 3 pi, you are adding minus subtracting C. So it goes in which quadrant? Second quadrant. So 3 pi minus C is in second quadrant. And since tan comes with multiple of pi, so tan will remain tan. Trigonometrical ratio remains trigonometrical ratio in terms of multiple of pi. So it remains and minus tan C. Why minus tan C? Why not plus tan C? Because it goes in the second quadrant. 3 pi minus theta is second quadrant tan is negative. So this goes like this. Now converting the numerators now, the numerators also you can see that becomes minus tan A, minus tan B, minus tan C divided by the same exponent denominator minus tan A, minus tan B, minus tan C. So it is plus 1. The answer is what? Plus 1.